Let's look at trig equation. So something like this. Tan theta is negative 2.3673. So how do we solve it? Well, first thing we need to know is where are we looking for answers? And they'll usually tell us that. Most common one is 0 to 360, but sometimes they like to get fancy and go from negative 180 to 180, things like that. Got to work out where we are in our little circle. Tan is negative, therefore I know I'm in the second and the fourth quadrants. Okay, we've got to get it back to that acute angle. So we need to find the acute angle. To do that, I would solve tan is equal to positive 2.3673. And that gets me 67 degrees 6. So now we can go and solve the problem. We'll put those two pieces of information together, what the acute angle is and which quadrants we're in. And I'll draw up a nice little picture. All right, so second quadrant, remember, was our 180 minus the acute angle, and the fourth quadrant was 360 minus the acute angle. Reality is I probably wouldn't write those last two lines down. I'd probably just go straight to those answers. So 112.54, 292.54. Okay, cos theta is a half. It's one of our exact values, but again, locate the quadrants 1 and 4. The acute angle is 60. In the first quadrant, everything's the same. Fourth quadrant, 360 minus, we get 60 and 300. Cosec equals 4. Well, it's easier to turn that into sine is a quarter because we need to use our calculator. So sine is a quarter. First and second quadrant is positive. Acute angle, 14 degrees 29. So we have 14.29 and 180 minus that, 165.31. Then we get fancy. But it's just like a normal equation. The difference is instead of making the pronumeral the subject, we're making the whole trig function the subject. So we've got to make sine x the subject. Sine x is negative a half. Third and fourth quadrants. Acute angle is 30 degrees. So 180 plus and 360 minus, 210, 330. Ooh, sine and cos. We really want the trig to be the same ratio. So what can I do with this one? Well, what I can do is turn it into tan theta, because sine on cos is tan. The tan theta is minus 2/5. Second and fourth quadrants. Acute angle is 21.48, so we end up with 158.12, 338.12. Cos 2 theta is 0.75. Now, we're told theta is going between 0 and 360, but we've got to find 2 theta before we can find theta. So I need to look between 0 and 720 for 2 theta. So we're going around the circle twice. Other than that, it's the same. So first and fourth quadrant, acute angle 41.25. So alpha, or 360 minus alpha, but in this case, I add 360 degrees to both of those because we're going around twice. Now I can divide by 2, and you'll notice all of those answers are between 0 and 360. Ooh, sec squared plus 10. Again, I want to get it all back to one ratio. This is where our trig identities come in handy. Because sec squared, of course, is 1 plus tan squared. We have a quadratic equation. The pronumeral in this is tan theta. What multiplies together to give negative 2, adds together to give 1. It's tan theta plus 2, tan theta minus 1. So either tan theta is negative 2 or tan theta is 1. So let's look at the negative 2. Quadrant 2 and 4, acute angle 63.26. So there's 2 of our answers. Tan theta equals 1. That's an exact value. It's in quadrant 1 or quadrant 3. 45 degrees is the acute. Possibilities, 45 to 25. There's all 4. I like to put them in order because I think it looks nicer. Now, one other thing to mention, none of our examples came up with this, but what you've got to be careful with, if 0 ends up being a solution, remember that automatically means 360 is as well. So if you're going between 0 and 360, make sure you include both. It's probably the most common mistake you see is people put down 0 and then they forget to put down 360 as well. 6H, and then from the old Cambridge, handful of questions there.